This is AP Calculus 4.1 through 4.3 test review. Problem number 1 says, explain how to use the graph below to prove the mean value theorem. Then find the local maximums and the local minimums. So first of all, in order to use the mean value theorem, we have to state a couple things. First being that f of x is a differentiable function. On the closed interval, (0 to 8), right? Because that's the graph that we are given here. F of x is a differentiable function on the closed interval 0 to 8. So what the mean value theorem says, the MVT says, there is at least one value c, perhaps more, but there is at least one value, and we're going to call it c, between a and b, such that f prime of c, which is the derivative at c, also known as the slope at c, is equal to f of b minus f of a over b minus a, which is the equation for the slope between the points a and b. Okay, so when we look at this particular graph, and if we were to draw in the slope line from a to b, which here is a and here is b, okay, so from here to here, if we were to draw in the slope, the line connecting these 2 points, oh, I undershot it a little bit, but you get the idea. Look something like that, right? Okay, so in looking at the graph, is there anywhere else where the slope would be parallel to that line at some particular point? And as you look at the graph, hopefully you can see, yes, there are multiple places where I would expect that the slope would be the same as that slope. So like right here, I would expect the slope to be the same. And right here, I would expect the slope to be the same. And right about there, and right about there, and right about there, perhaps, right? All of those spots look like if I were to find the slope at that point, right? If I were to find the derivative of the function at that point, I would get the same value as I got, okay? So basically our conclusion here is, in looking at the graph, there are actually 5 values, at least that's what I marked on my graph. There are actually 5 values where this is true. And those values are approximately x equals 1/2, x equals 1 1/2, x equals 2 1/2. I'm just approximating these. X equals 5 1/2. And about x equals, maybe x equals 7. 6 1/2, 7. Okay. And then the other thing that they asked us to do is find the local maximums and the local minimums of this function. So those are local max and mins. Obviously, we're going to have one here. We're going to have one here. Sorry, right here. We are going to have one right here. And that's about it. Okay. So when we look at those, x equals 1, and it might be hard to see because of those slope lines that I drew in here, but if I erase this a little bit and I look at that, Notice that I sort of have a bit of a horizontal stretch right here in my graph. And so by definition, x equals 1 is going to be both a local maximum and a local minimum, because remember, the definition of a local maximum is that the value is higher than or equal to points on the left side and the right side. Well, in that case, it would be equal to, right? And the definition of a local minimum is the same, lower than or equal to points on the left and right sides. So for my local max, I would say x equals 1, and I would say I have a local maximum at x equals 5, right? And the value of my function at x equals 1 is 1, right? So we don't have a function here, but we'll just say f of 1 equals 1. And f of 5 also equals 1. Okay, so those are the actual values of the maximum. And then local min, we already discussed that x equals 1 is also a local min, right? So I already know that f of 1 equals 1. But then I have another local minimum at x equals 3. And f of 3 is negative 1. Okay, so that is problem number 1. Now taking a look at problem number 2, also about the mean value theorem. It says, use an example of traveling in a car to show that the mean value theorem is true. Okay, so basically in problem number 1, we were given a graph, and in problem number 2, we are expected to create a graph. So let's draw a picture of what driving in a car might look like. So on my x-axis, I am going to have time. And again, I've got some interval from A to B here. And on my y-axis, I am going to have the velocity of my car. And so, I don't know, I might go from like 10 miles per hour up to about 60 miles per hour. Like so. And as you can imagine, when you're driving down a road, first of all, speed limits change, right? So your velocity can certainly increase, and then it can start to decrease if you have to slow down. But there are other factors, like you could have to brake suddenly because an animal runs out in front of you, or because the person in front of you brakes suddenly. So there's all kinds of reasons why your speed might change dramatically, either increasing or decreasing. So I would assume that if I'm starting at A, and we'll say that A is at 0, and we'll say that the end of our interval B is somewhere over here, that I'm speeding up, and maybe I'm going 30 miles per hour for a while, and then maybe it changes to 60 miles per hour, but then it changes back to like 25 miles per hour, and then it goes back up to 60 miles per hour, right? This is just an example of what our graph could look like for the velocity of a car. And so here's the end of my interval at B, so I'm going to put a dot right there. And so just like I did in the other graph, if I was going to sketch the slope line between A and B, I'm going to give this my best free-handed shot here. The slope between points A and B is going to look like that. So basically the idea here is just to show that the mean value theorem is true, to show that there has to be some other point on this curve that has the same slope as the slope of the tangent line. And of course this is true, right? There's probably a point right here where the slope is the same as the tangent line, and a point right here where the slope is the same as the tangent line, and a point right here where the slope is the same as the tangent line, and a point probably right there where the slope is the same. So lots of points here, right? So in conclusion here, we can say that f of x is a differentiable function on the closed interval a to b, and so I know that at any given point in time, the average speed of my car is going to be equal to f of b minus f of a divided by b minus a, right? And there are plenty of locations on my graph where that value, which, sorry, I should have written that this is my slope average here, right? M average, where I get that same value, right? So like right here, we'll call this C1. Right here, we'll call this C2. Right here, we'll call this C3. And right here, we'll call this C4. Okay? So then we can say that f prime of C1 should be equal to f prime of C2, should be equal to f prime of C3, should be equal to f prime of C4, should all be equal to my average slope. So there's an example of traveling in a car to show that the mean value theorem example is true.